Yeah. Not much to do. Yeah, you ain't got to tell me twice.
Come back and take you
What How are you doing? How'd the weekend go? How many games did you have? And you work on for what, 5 days, 4 days?
Well, yeah, we had a game, we left Wednesday, had a game Thursday, practice Friday, game Saturday.
Well, she's my lab partner, so I kind of know. Do you want to do my lab partner?
Recording the...
Oh. Hey! Let me just turn it back here. That's kind of funny. Yeah, I'm gonna have to move tables.
Oh, is she just keeping it there the whole class? That's what she
Is that what she's doing? Just like recording it?
I didn't get one.
So, anything you
Everything you say. Slide me forward.
the whole class. Or is that like one person?
Alright, who needs pictures for the poster?
Oh, I do. Can you send it to me?
I'm going tomorrow, so.
Why don't you just get on her computer and use the...
Well, I was probably going to, but
Get on the computer and
people were paying me to do it. Are you keeping the pink? The pink on your shirt. You're keeping the stuff with the pink. There's pink on your shirt.
I didn't know there was.
You didn't know there was pink. You didn't even see them?
The only time I've worn this has been at night. So, it's the first time I've worn
Is it comfortable?
it.
I got one. I got one.
But like when you first get them, just like any stuff with a letter in your hair.
Yeah, but like I got one, but it's all pink, so I just like telling Moser, like, a lot of our stuff's pink, what do we do? And he goes, I don't know, I'm getting onto it right now. So apparently they're gonna return it all and get it back.
I will wear it with pink.
like, get a picture of the bun.
Yeah, it's fine. I tried to get
We don't need,
color.
like, real pictures.
I tried to get color. Why do I have this terrible speech? What is that? Tear it in half. Can you just tear it in half for me, please? Thanks. You're a doll. Here you go. You're better at it. I gotta get cornucopia.
That's not gonna happen.
Cornucopia is Hawaii coffee. It's the best coffee in the world. It's also very expensive. Yes, Hawaii. Free shipping! Oh! Yeah, that's right. I got free shipping. Oh, over $99. Oh, it's cola coffee. Cola coffee.
Are you gonna be able to go there?
I don't know. I should be. I know you have basketball.
No.
Is it that good?
On Thursday, it's on the phone.
You must spend $100 on coffee.
Nah, it's 40.
Thursday, I've talked to myself for
I could go from like 11 to 12. Yeah, that's terrible timing.
One of your partners has to be there.
I know, but if both of us have class, like, why are you going to schedule it in the middle of the day when I have class?
The only time you can. You gotta be there both days.
Ladies and gentlemen, you have on
Unless
the
you have
table
like
in front of you
a class.
a little piece of paper, and on one side of the little piece of paper are thermochemical calculations, but on the other side of the little piece of paper are two problems that you need to now work. Because you remember how. Yes.
That's funny.
Should you get your pictures from the computer? And you got a question, like you're telling me, like,
These work.
the data that we collect, people will repeat. So you make a graph. Of course, you put the different.
What's up?
What chapter was it?
What?
You're working a problem.
Oh, you have the book?
I don't know. Not a clue.
Brown or whatever. Well,
I wasn't here for all this stuff. You can do it now, show me.
I was gonna use
So you're working problems. I don't know what
we'll work the problem first. I don't know what chapter.
That's why you're not in Partner.
Yo!
What chapter is it? Don't you know?
Chapter?
Yes,
In the
chapter
book.
10. Chapter 10? Okay.
Yeah, you're welcome.
Thank you.
Oh.
So I'll go to chapter 10.
And those are from last week.
Okay. Oh.
What?
Oh, you talking to her?
Yeah.
Okay.
Yeah, I sent her the PH. My PH results.
Who's talking about?
Your face.
Chapter 10.
You got this one?
$4.
Online?
Yeah. About $5, I think, was it? Yeah, well, mine was a penny, and I paid $3.99 shipping. Well, right. So it was $4. So it was $4. A penny for the book and $3.99 shipping. Remember, I've been telling you about that? Not bad. Not bad. No, you like it still go on and get it.
I don't need it anymore.
He's done with it. Because he's not taking Kim 2. How many of you in here are taking Kim 2 in the spring? You need to consider over the Christmas holidays purchasing the book. Miss Lacey, how old the book up? The book looks like this. It's the one that's attached that we, the references are out of. $4. Book is a penny, the shipping is $3.99. Can't beat it.
Amazon Prime.
Amazon Prime, that's right. So you can't beat that. Good book. That's correct, but if you bought the new one right now, it's $379. So pay the penny. Well, buy the one for a penny and then buy yourself a new pair of boots. Yeah.
I just need
I got a pair of training clothes in my red. Oh, you already took your bio?
No, I'm taking that next semester.
Okay, I'm taking it. You're crazy.
Psychology.
I told my boy, I know you just did. That's it. And then.
I'm taking biology and biology and social. Yeah.
And you go to organic?
The summer I'm going to start taking that in the morning.
I took that ABCD under, anyway, I got a B in it, but they told me here it transfer because it was considered,
A lesser, they're not equal.
yeah.
Yeah, if you go to student services, they'll print out the paper of all the ACC classes and like their equivalent.
How can it not even, it's gonna be the same stuff?
It's like, here it's harder, and so it doesn't.
Okay, what are we talking about?
If you were to take like anatomy and
Anatomy already, okay, what's the course number on anatomy? They already told me it didn't transfer. Yeah, it's a lower division course.
Yeah.
Here is a junior level course. That's why it's actually.
And I got a B in it.
Well, but one of them's anatomy and the other one's physiology. Both of ours are anatomy and physiology, and they're under each class. Transfer history and English.
Yeah.
I'm gonna take it back home.
If
I'm taking it
like
this
the
one.
ANPs 1 and 2, if you take APCC
Yeah,
and
it should be
NPs, then it's
it's anatomy and physiology
that's something
together.
cheaper.
Yeah.
Yes, it does, but it doesn't give you the same information.
I was gonna find out if the
sophomore
transfers
level
like
course
that.
here is
Yeah. It's,
Actually, I might have taken it anyway.
yeah, it doesn't, like, not equivalent.
They told me it was.
No,
They
that's,
told you that you can transfer as an equivalent. They didn't tell you you were going to get the same information.
My
So
daughter's
like you can
same
take
like
Chem
you.
1
I just-
and
My daughter's
ACC.
like
The people who
I
can't take
tried,
Chem 1 and
but
ACC
that's
and come in and made an A or a B,
You don't try.
generally
I
have to repeat
tried.
Chem 1 here because they can't take the
I tried.
formative
A lot of
assessment
people
in Chem 2
that
and
you
actually
are
pass it
really
with
smart,
above a
so.
12 to a 28.
That would have been my brother.
Be really
Me, I
careful.
struggled. I'm one of
Decide the
those
transfer.
didn't have to go over. and
Especially if
over.
you're
Yeah, no, I
taking
just study it.
something that has a 1 and a 2 and you take 1 somewhere else and expect to come in and take 2, bad idea. It doesn't work well for you.
So once I study it, that's
Well, you can use this book to.
yeah, I was gonna look at that, but not right now. Pretty much do this problem, I guess.
No, you didn't.
754? Yeah. 754.
Okay, so ladies and gentlemen, you were working on a gas stoichiometry problem in the closet. Yeah, I guess it You divided it? No, you divided it with 1 over.
How'd you do this problem?
The first one?
Yeah.
Well, I have a different sheet, so I don't
You have a
know.
different sheet than me?
I guess. Well, I think I just got the whole sheet.
No, let me see.
Yeah, they're the same thing.
Yeah, I'm talking about number 1 right there. Didn't do that yet?
No, I just started.
What's the equation again? Pressure equals
TV equals NRT.
well, I know that, but what's the other formula?
Molarity equals moles divided by volume. Thank you. Thank you.
Is that Spanish?
That's, yeah. It needs help. It literally needs help, but it's what. Oh my god.
Yes, yeah, I got it. Okay, ladies and gentlemen, did everybody finish the stoichiometry problem? Yes, no, you should have already seen it. It was in the packet for test number 3. So this, test number 2 to test number 3. Anybody have an answer? 0.953 grams. 0.953 grams. Anybody else have an answer? 0.96, okay? 0.953, that's good. What else? Okay, anybody in the back have an answer? 0.96. 0.96. Sounds like we've got 0.96 for an answer on this particular problem. So you have something that you're shooting toward. Okay, the last problem, the second problem that's on there is a molecular formula problem. What are the steps in working a molecular formula problem? First, assume that 100 gram sample. Yes. You assume a 100-gram sample, convert from grams to moles, divide by the smallest, you get a ratio. Use that ratio to write what? The empirical formula. After you get the empirical formula, you calculate the molar mass of the empirical formula. If it's the same as the molar mass given in the problem, you are done. If it's not, what must you do? Divide the molar mass of the molecular formula by the molar mass of the empirical formula, and then you get a multiplier. Does that multiplier go out in front as a coefficient? No, it doesn't. It has to be used as a subscript. So you have to multiply by the subscript. Okay. So we are going to move on to looking at thermochemistry. We have a couple of problems that we're going to work. But I want to remind you that the comprehensive makeup exam is tomorrow at 5:45. It's in Building B, which is the study lounge. All of the material out of packet. Yeah, that's a cheat test. Number 2 and number 3, and out of packet test number 3, the comprehensive makeup exam, we're doing thermochemical calculations, conceptual thermochemistry, and percent yield and limiting reagents. This test is purely optional, but it's also no fault. So if you make a really runny grade on it, you will just use it as a study guide. You must stay till 6:55 and turn in a Scantron and an essay to leave with the exam. You need a calculator. Don't forget your chemicist, and you need a pencil or 2 or 3 because there are no pencil sharpeners over there in that room. You might also consider bringing Kleenex if you are in the grips of allergy season like many of us, and water to drink if that's needed. Again, this is optional, so you don't have to take it if you don't want to. It will replace your lowest test grade if you've taken all your tests. Some of you have missed a test and need to take this particular one. Any questions about the comprehensive makeup? I believe this may be the first time ever in my life where nobody has raised their hand and told me that they have to work. You're not coming to the comprehensive makeup exam? Sir? He's not going to take it. Oh, okay. Well, hopefully you have really good friends in the class. What else? Anybody else? So here's what you need to know. There are 10 calculations. So they are worth 5 points apiece. There are 20 essays. There are 20 multiple choice questions. Yeah, that'd be bad. There are 20 multiple choice questions, and they're worth 1 point apiece. That's 70. Yes. So the essays, the problems are worth 6 points apiece. The multiple choice are worth 1 point apiece, and the essay is worth 20. Okay? So that's sort of where we are with all of this. Do the problems first. And that's again, you need to do the problems first. They're the ones that are worth the most. And then do the essay question. Or do the essay, do some problems, do the essay, and go back and do some more problems. I don't know how your persistence and your endurance is with working problems. So you might consider that. We have never had more than 6 calculations on a test before. So this is 10. It will take 2 hours, yes ma'am.
So one of the 3 essay questions.
It's going to be one of the 3 essay
What is that
questions.
at the bottom? The packet for
So you
test
don't
3
log it
to
in.
That's the very last one. That was very last.
Are those three things going to be on the CME? Or are they going to be on the
I'm going to give you two, and you can take one of the two. So as long
Right.
as you know two of them, you should be fine, right? Okay. We're looking at calorimetry today.
So choose one.
We talked about calorimetry before. This is a way of finding out about the energy content within a particular chemical compound. We also talked about heat capacity and
Bump the
specific heat.
X86 up.
The heat capacity is the amount of energy required to raise the temperature of a substance by 1 degree
If I
centigrade.
could do on the final one.
Specific heat capacity is different, is that it's 1 gram of a substance by 1 degree K. Specific heat is equal to heat transferred divided by the mass times the change in temperature. Looks like that. Or you can spread it out and have it look a different way. We will do that in a little while. Constant pressure calorimetry. In constant pressure calorimetry, this usually uses a coffee cup, double to be insulation, a stirring rod, a thermometer, all of that. Delta H for constant pressure calorimetry is equal to what? Delta H is equal to what? It was that derivation that we did the other day when we substituted in for heat. It is. It's equal to heat. That might be one of those things that you might want to know something about. It will help you with the calculation. Here's another way of looking at specific heat, where it says heat is equal to mass times S. S is specific heat times the change in temperature. What are the units on temperature for this equation?
Celsius or Kelvin.
Celsius or Kelvin, because the difference in temperature is the same, because the difference between units are the same in Celsius and Kelvin. There is constant pressure calorimetry, that's the coffee cup stuff. There is bomb calorimetry, it is carried out at a constant volume. It's a different type of arrangement. It's a more complex situation. Because the volume of the bomb calorimeter is constant, what's measured here is really the change in internal energy, so it's delta E, not delta H. In constant pressure calorimetry, we measure heat and we get delta H. In constant volume calorimetry, we actually get the change in internal energy. For most reactions, the difference between these two are very small. So here's a bomb calorimeter and sort of how it works. I don't have the video that goes with it. We're also you are going to look at something known as Hess's law. Delta H is well known for many reactions, but it's inconvenient to measure delta H for every one of those reactions. So Hess's law is our solution around that, because delta H is a state function. It doesn't depend on the individual steps, only the beginning state and the ending state. So here's where you are going to make a note on your notes. We can estimate delta H using delta H values that are published, properties of enthalpy. You can find them in textbooks, you can find them on ThinkWell, but even more, this is going to be on the exam tomorrow night, and you will find it well developed and well explained in your ThinkWell video system. There is a 9-minute and 46-second video telling you about how Hess's law works, complete with notes to give you information as to how to work these particular problems. My suggestion is to go for it at this point. Okay, because it is a 6-point question and it is on the test tomorrow. However, at this point, we are going to look at the problems that are on the little piece of paper that you have right there in front of you. And we're going to do that with a handy dandy document camera that just came up. So these are the problems that we're looking at in thermochemical calculations. And we're going to start out with the first one. Which says how much heat is needed to warm 250 grams of water, which is about a cup of water, from 22 C, which is about room temperature, to nearest boiling point, 98 C. The specific heat of water is 4.18 kilojoules per gram degree Kelvin. So, here is our handy dandy problem. Things that you need to know. The equation that we're going to use to solve this one is Q is equal to specific heat times the mass times the change in temperature. And if we go back and we look at this particular problem, we can find all of those things. The question here that you're trying to find is how much heat. So heat is what we're looking for. And the things that we know are that we have 250 grams of water, that's our mass, that we have a temperature of 22 C and another one of 98 C. So from those two, we can get our delta T. And we need the specific heat of water, which is given right here in that particular instance. So we have all the information we need. We know that the specific heat of water is 4.18 joules per gram degree Kelvin. We know that the mass is 250 grams. And we know parts about the change in temperature. We know that the final temperature is 98 C. We know the initial temperature is 22 C. So we know that there is 76 C or K difference between the two. Okay, so we have all of that information. What we're solving for is heat. That's Q right there. So we have Q is equal to 4.18 joules per gram degree centigrade times the mass, which is 250 grams, times the change in temperature, which is 76 C. What do you think we're going to do next?
Multiply.
No.
Cancel labels.
We're going to cancel units. We have centigrade in the numerator and centigrade in the denominator. We have grams in the numerator and grams in the denominator. We end up with units of joules, which is a good thing because that's what the units are for heat. And we end up with 7.9 times 10 to the fourth.
Can you take it up some?
Joules. So, the problem, we read it. It said how much heat, so we know heat's what we're looking for. We have an equation that relates heat to specific heat and mass and a change in temperature. We have the mass of the water. What if they told us that we had 250 milliliters of water? What would we do? Would we wring our hands and go, oh me, or would we remember something about mass and volume? What relates mass and volume? Density relates mass and volume. So if we know the density of water, which is 1 gram per milliliter, then if we have 250 milliliters of water, we have 250 grams of water, okay? What if we had 250 milliliters of alcohol and we were told that the density is 0.89? What would we have to do? We'd have to do some math. We'd have to convert that and use the density as 0.89 grams per milliliter and figure out what the mass of the solution was. Okay, after we know what we're looking for, heat, and we have specific heat and mass and two different temperatures, we know that we're looking at this particular formula. If we write down everything we know, remembering that the change in temperature, notice that this particular equation gave us the specific heat of water in degrees Kelvin. It can be 4.18 joules per gram degree Celsius also. So don't let that mess you up. It did that to me once upon a time, and I don't want it to happen to you. So you substitute in for specific heat, for mass, for change in temperature, do the arithmetic, and you get Q in joules. If you always go back and check to make sure your units cancel, you will avoid using factors upside down, or reciprocals of factors. So let your units work for you and gain points for you and keep you from making mistakes. That is problem number 1. Anybody have any questions? Okay, no one spoke up. Time to move on. We're going to do problem number 2. Problem number 2 says, how much heat is released when 4.50 grams of methane gas is burned in a constant pressure system? 890 kilojoules, it should be R, are released by the system when 1 mole of methane is burned at constant pressure. So delta, you see it doesn't show up right. It didn't translate as delta H is equal to minus 890 kilojoules. So we're going to look at problem number 2. And in problem number 2, once again, it asks us how much heat. So heat is what we're looking for. Is released when 4.50 grams of methane gas is burned in a constant pressure system. It tells us in the system that we have 890 kilojoules released by the system. If it's released by the system, what's the sign?
Negative.
Negative. This has got a negative sign on it, and you know that only from the word. Okay? And this down here will then say delta H is equal to minus 890 kilojoules. So we know that 1 mole of CH4 gives us 890 kilojoules, and we know that there is a negative in front of it right there because those kilojoules are released. Okay? So the heat that we're looking for is equal to the number of moles times the number of kilojoules per mole. Okay? So we have to find out how many moles of methane we have. Were we given that in the problem? Actually, we were given how many grams of methane that we have. So we're going to take grams of methane and we're going to convert it into moles of methane. So we have 4.50 grams of methane. We're going to multiply it by something to end up with moles of methane. 1 mole in the numerator, what's in the denominator? 16 grams in the denominator, and we end up with 0.281 moles of methane. So now to get heat, which is what we're looking for, Q is equal to 0.281 moles times minus 890 kilojoules per mole. So our moles and moles cancel, and we end up with minus 250 kilojoules for the heat that's generated. How many significant figures in the problem?
3.
Oh, there are 3, because the 890 is a given, is a definition. So what must we do to minus 250? How do we turn 250 into 3 significant figures? We could do that. We could put a decimal there, or we could write it as 2.50 times 10 to the 2 kilojoules, but that would give us our 3 significant figures. Anybody have any questions? What you need to know about this is that the material that you were given that is current knowledge, that you might read off a chart, is a definition. So whatever, it doesn't have any impact on your significant figures. But the delta H values off a chart are kilojoules per mole, because that's how much energy is released per mole of whatever substance it is. This problem told us that we had 4.50 grams. So we have to figure out how many moles that we have of that stuff, because that will then tell us how much heat it's going to release. It's the difference between the little canister of propane and the great big tank. We didn't have a whole mole of methane, so we didn't get minus 890. We had 0.281 moles of it, so we got 250 kilojoules. Okay? if you were thinking about how this was going to, how this works. Okay, any questions about this one? If you have a question, speak up. I guess I could turn this around a little bit. That way I can see you, but I can still have a hard time seeing this price and this price. Yeah. It should swivel. It should, but it's here. Oh, look, all the way back around. That's better. I can look around here and see Mr. Cup if he can cut his hand. Okay, so that was problem number 2. We are moving on to problem number 3. Now, problem number 3 is a little bit more involved than the other 2. So let's look at what it says. It says how much, no, it says when a student mixes, oh, we're doing chemistry finally. When a student mixes 50 milliliters of 1 molar hydrochloric acid with 50 milliliters of 1 molar sodium hydroxide in a coffee cup calorimeter, the temperature of the resultant solution increases from 21C to 27.5C. Calculate the enthalpy change for the reaction in kilojoules per mole HCl. Assuming that the calorimeter loses only a negligible quantity of heat, that the total volume of the solution is 100 milliliters, and that its density is 1.0 grams per milliliter, and that the specific heat is 4.18 joules per gram degree Kelvin. Man, it gave you all the constants in there. Did it have to tell you that? Did it have to tell you that there was 100 milliliters?
No.
Yeah.
It didn't, because it said it had 50 milliliters and 50 milliliters. It should tell you that, does it need to tell you the density of an aqueous solution? No, probably not, because you'd know that if it was aqueous, it was in water, right? And the specific heat of water is 4.18 joules per gram degree Kelvin. That's one of those constants that you probably need to know. But I'm going to give you tomorrow night. Okay? So we're going to look at this particular type of reaction and see what we have. What do you think the first thing we're going to do in this particular problem is? Write down what we know is a good thing. It's a problem in chemistry. What do you think? What kind of problem is it? How about we'll try that first? Yeah, we do. We need to write down the chemical equation. You are absolutely right. This is an acid-base reaction. It combines hydrochloric acid, which is aqueous, plus sodium hydroxide, which is also aqueous, and we get a salt, sodium chloride, in aqueous solution, and we get water, and this time our water is not aqueous, it's liquid. In fact, the driving force behind this reaction, the reason energetically why it occurs is because we make liquid water. We pull ions out of solution, a hydrogen ion and a hydroxide ion, and we make water. So what we've been asked to calculate is the heat produced by the reaction, RXN, per mole of HCl. Okay? So we need to know how many moles of HCl there are here. Let's look. We have 50 milliliters of 1 molar HCl. Can we figure out how many moles that is? Oh, don't all jump in at once. Can we figure out how many moles of hydrochloric acid are in 50 milliliters of 1 molar hydrochloric acid? We're going to multiply the molarity times the volume, and it's going to give us the number of moles, right? And we have 50 milliliters of 1 molar sodium hydroxide. Can we figure out how many moles of sodium hydroxide there are? Yes. We can. The other thing that we're given here is that we have a change in temperature. It says it increases from 21 to 27.5 C. Is this an endothermic or an exothermic reaction? Well, if it goes from 21 and then the chemical reaction occurs and it's up to 27.5, did it release heat or did it gained heat? So and so the sign on this delta H for this reaction is positive or negative. Okay, we'll try again. All right. So we have this chemical reaction that's done in this water environment. We take the temperature of the water to start out with, and it's 21 degrees centigrade. Then we mix the hydrochloric acid, we pour it in there, and the temperature goes up to 27.5 degrees, and it's an exothermic reaction. We've agreed on that. Is the sign on delta H and Q negative or positive?
Negative.
It's negative because the heat's been released, right? And that means the sign is negative. Now there's a bunch of other stuff that we were given here. We were given that the total volume of the solution is 100 milliliters, that its density is 1, and its specific heat is 4.18 times 4.18 joules per gram degree Kelvin. Yes, Mr. Van Winkle?
I thought we just saw that it was an endothermic reaction.
Okay. The temperature of the resultant solution increases from 21 to 27.5. After the chemical reaction heats up and it releases heat into the water solution, so the temperature goes up. If it was an endothermic reaction, then the chemical reaction would have sucked heat out of the solution, would have taken heat out of the solution
And brought it in.
And the solution will feel cold.
Oh, so because the solution and not the actual endothermic.
Well, the solution tells us that the chemical reaction occurs in the solution between the sodium hydroxide and the hydrochloric acid. While those things are in there, they're in our aqueous solution, and when the chemical reaction between the molecules occur, it releases heat. Where does it release it to? The water that surrounds it. So the temperature of the water goes up because the molecules are releasing heat to the water. In a chemical reaction that's endothermic, like putting Alka-Seltzer in water, okay? The Alka-Seltzer dissolves, and after it dissolves, or as it dissolves, it creates carbon dioxide bubbles. And so the bubbles come up at the top, right? Well, it takes energy to go from a liquid to a gas. So that energy has to be taken from somewhere because, right, the energy of the universe is constant. So if the energy of the universe is constant, then it has to take the energy from somewhere, and that's the solution around it. So if it pulls energy from the solution, does the solution feel hot or cold? It feels cold because it's got less energy than it did before, so it feels cold. We'll have to do this in class on Wednesday. I was planning on doing it today and didn't get to it. But we'll do it in a Ziploc bag, and then it'll give you something to remember and you'll understand. But when you put a strong acid with a strong base, it's going to make a lot of heat, and that's an exothermic reaction. The way that you know it's exothermic is because the water heats up, and that's what's happened here, okay? Okay. So we need some information about in here if we're going to calculate heat, because we know heat is equal to specific heat times mass times the change in temperature. Yes. So the specific heat of water we are given is 4.18 joules per gram degree, we'll say Celsius, okay? We need a mass. We're told that we have two different solutions and we need to get the mass. We can do that in a minute. And we need a delta T. We're given two different temperatures. The final temperature is 27.5 C and the initial is 21 C. And so our answer here is 6.5 C. How do we get the mass? Well, we have 50 milliliters here and 50 milliliters there. And if we assume that they just add up, how many milliliters do we have? 100. If we have 100 milliliters in an aqueous solution whose density is 1, what mass do we have of our solution? Okay, I'm going to say it again because I'm not getting answers and I really want them. We have 50 milliliters that come from this solution, and we have 50 milliliters that come from this aqueous solution. We have two aqueous solutions. We add them together. We end up with 100 milliliters. Since they are aqueous solutions, we assume their density is 1 gram per milliliter. We've got 100 milliliters, and the density is 1 gram per milliliter. What is the mass of our solution? 100 grams. Okay, so now we have a specific heat, we have a mass, and we have a change in temperature. Q is equal to specific heat times mass times the change in temperature. We have 4.18 joules per gram degree Celsius. We have 100 grams, and we have 6.5 degrees C. Degree C cancels degree C. Grams in the numerator cancels with grams in the denominator. We have an answer in joules, which is 2.7 times 10 to the 3 joules. Now, normally we use kilojoules, and our kilojoules come from 1,000 joules, so we have 2.7 kilojoules. Now, I ask you, what type of chemical reaction was it? It was exothermic, and the sign on an exothermic reaction for heat is positive or negative? Negative. So we put that negative right there, and there is no way in the chemical problem that you can figure out that it's there, except for reading the problem and looking at the temperature and see that the temperature went up, so heat was released. So that negative comes from released heat. Okay?
Let's move it up a little bit.
You have to figure out where the released heat, what the sign is on this cube based on what you're told in the problem, and looking at the change in temperature, whether the temperature went, the original temperature is higher or lower, the final temperature is higher or lower than the original temperature. Now, we were told that we needed to calculate the heat produced by the reaction per mole of HCl. How do we get moles of HCl? That's right. So we need moles of HCl. We're going to get that by multiplying the molarity times the volume. It's going to give us the number of moles. The molarity is 1 mole per liter, and the volume is 50 milliliters. So we're going to end up with 0.050 moles. So if we want heat per mole, we're going to take the 2.7 times 10 to the 3, and what's the sign on it? Negative. And we're going to divide it by 0.050 moles. This is moles. This is joules. And we're going to end up with minus 54 kilojoules per mole. Yes?
Why did we use this negative 2.7 times 10 to the 3 if we converted it to kilojoules instead of 2.7?
You're right.
Yay.
Here we go. Okay, so the question in the problem was, let me read it. Calculate the enthalpy change for the reaction in kilojoules per mole of HCl, assuming that the calorimeter loses only a negligible quantity of heat. So we're going to assume the calorimeter is working well. That the total volume of the solution is 100 milliliters, 50 plus 50, so our delta G of mixing is 0. And the density is 1 gram per milliliter. There really is water in our solution, and then it gives you the specific heat of water. So it is a chemical reaction, so you're going to look at it and see that it's a 1-to-1 relationship between hydrochloric acid, sodium hydroxide, sodium chloride, and water. What if this had been sulfuric acid? It wouldn't have been the same, would it? No, because we'd have a different coefficient in some of the other pieces of information. Because it was one-to-one, it worked out like this. If someone was sneaky and gave you a question and asked you about a different acid, or not one that was not one-to-one, then you need to look at what the question said. How much information do I need to give you on this particular problem for you to be able to work it? Well, you have to have something to get the mass, right? In this case, you have two 50 milliliter samples that add up to 100. Do I need to tell you that the density of water is 1?
No.
No, you should know that one, okay? And do I need to tell you the total volume of the solution? No, because it tells you you've got 50 milliliters of one and 50 milliliters of the other. So it's got 100 milliliters and it's got a density of 1. The specific heat of water is 4.18 joules per gram degree Kelvin. I'm going to tell you that. But I may not tell you in the problem. I may tell you on the board, or I may put it in a list of constants or something. So you need to remember. So the thing that you really need to remember here is this piece right there, so that you know that heat is equal to specific heat times mass times the change in temperature. Now you see this written differently on the PowerPoint because it writes it as specific heat is equal to something. This one right here provides you with less opportunities to make arithmetic mistakes. So if you're going to memorize something, that's probably a better one to memorize. Okay, anybody have any questions? Yes, sir. For the temperature right here, I took 27.5 right up here and subtracted 21 from it. Okay, so it's a difference in temperature. Anything else? Okay, I've had several emails asking about molecular geometry, bonding, and intermolecular forces. They are not on the comprehensive makeup exam.
Wait,
What?
Right, what's on the comprehensive makeup exam is up here. Thermochemical calculations, conceptual thermochemistry, and the limiting reagent % yield problems that are in packet 2. The molecular geometry, bonding, and intermolecular forces will be on the fine.
Okay.
Okay? Anybody else? There's 3 essay questions. I will give you 2 and then choose the one you want to answer.
So if I do one, I have a 30% chance of
That's right.
Great. So you can't just pick one?
You